Guys, so we're going to work through homework 6.3. This is day 3, and we have 4 problems to do. The first one is number 49. The table shows the distance, y is in miles, and as an astronaut, that's how far they'd be able to see. X is in feet on the surface of Mars. So we need to write a function, and we're going to talk about what is the distance an astronaut could be able to see if they were at 10,000 feet. So step 1, just write the function. To be able to write the function, we're going to write one more column right over here. And this is going to be new function. Okay. We're going to call this square root of x. Go to your calculator, and we're going to start using the square root of x. So new document. Add in a graph, and then type in the square root of x. At this point, you can either press Control-T to pull up your table, or you can go to Menu, Option 7, which is Table, and then Split Screen. So the x values they give you are 1,000, 2,000, 3,000, and 4,000. To get to 1,000, it's not going to let me just get all the way down to 1,000. So what I'm going to have to do is go to Document, Insert, a Calculator, and I'll just type in F1 instead. So I'm going to use all of these x values. The first one is 0. F1 at 0 is 0. So that's what I'm going to write here. Now I'll type in F1 of 1,000. And that gives me 31.623. So F of 2,000 44.721. F of 3,000 is 54.772. And then F of 4,000, so you type in F1 of 4,000, and that's 63.246. Alright. The very last thing we're going to do, and it's one more column over here, we're going to put the distance y divided by this square root of x column. Okay? So in other words, 0 divided by 0 is 0. And now we're going to do 28.2 divided by 31.623. So here we go. We're going to do 28.2 divided by 31.623. That's going to come out 0.892. So we'll write that down. 0.892. Let's divide the next row. The next row says 39.9 divided by 44.721. So 39.9 divided by 44.721. Alright, that's 0.892. We'll go on to the next one. This is 48.9 divided by 54.772. And we get 0.893. And I'll divide 56.5 divided by 63.246. 0.893. So in general, the number that we're getting here is 0.89. It could be, 0.2 or 0.3 hundredths out of the way, thousandths out of the way, but that's okay. We're just going to do 0.89. Okay. So this is our equation right here. The whole reason that we did this step, that we divided, is so that we could get our equation. We started with y equals the square root of x. That's this column right here. And now we know that the coefficient is 0.89. Okay? So this new equation that we're going to use is y equals 0.89 square roots of x. We're going to use this equation, and they ask us to substitute in. They say, what is the distance that an astronaut would be able to see if they were at 10,000 feet? So the feet is the x variable, so we're going to substitute in y equals 0.89, and instead of x, we're going to replace that with 10,000. Alright, so let's see here. What is 0.89 times the square root of 10,000? And it equals 89. So 10,000, 89 is the coordinate point that they're talking about. In other words, at 10,000 feet, an astronaut could see 89 miles. And we'll match that coordinate point up. 10,000 is the x variable, so 10,000 feet, and 89 was the y variable, so that's miles. 89 miles. At 10,000 feet, astronaut can see 89 miles. And now let's look at number 50. The table shows speed of sound waves. The y value is speed, and the x value is temperature. So it's asking for what is the speed of the sound wave when the air temperature is 250. So they're going to give us 250. We're going to substitute it in for x, and then we're going to see what y equals. So to be able to get this, we need to make our extra column. And we are thinking the square root of x. Now what's nice about this is I can just use the exact same square root function that's already in here. Y equals the square root of x is already in here. And I just need to change the x values. Now I'm not looking for 1,000, 2,000, 3,000. Now I'm looking for 100, 200, 300, 400. So we'll go back to our calculator page. This is at the top 1.2. And we can just type in F1. And the first one that we want to do is 0. And that gives us 0, so we'll write that. And then we'll try F1 of 100. That gives us 10. F1 of 200 is 14.142. F1 of 300 gives us 17.321. And F1 of 400 gives us 20. And now we're ready to set up our division. So we're going to divide 0 divided by 0, 10 divided by 200, 14.142 divided by 283. And we're going to see if we can get a number to pop out of this. This is y divided by the square root of x. Okay. 0 divided by 0 is just 0. We're going to take 10 divided by 200. And that gives us 0.05. We're going to try 283 divided by 14.142, and so on and so forth. So again, we've got 200 divided by 10, that gives us 20.00. 283 divided by the 14 here is going to give us 20.011. And 347 divided by 17.321 is 20.033. The very last one is 401 divided by 20, which is going to be 20.050. So you can see that we're converging around about 20. So this should be y equals square root of x. And what we're seeing from our data table is that it's closer to y equals 20 square roots of x. They ask us to substitute in 250 for x, so y equals 220, and we're going to multiply that against the square root of 250. So 20 times the square root of 250 is going to be 316.288. Y equals 316.288. And then we'll write our sentence. So the coordinate point, 250, 316.288. So now it's time to write our final sentence. Alright. When the temperature is 250 degrees Kelvin, sound waves travel at 316.288 meters per second.